Greetings, and welcome back to Mr. Wong's Distant Learning. In the 7th week, Monday's May 11th edition, reviewing the concept of integers, adding, subtracting, multiplying, and dividing. The homework for this lesson will be the final 2 questions on the slide, and also downloadable on eCampus. Let's proceed. Let's review the rules for adding integers. Adding integers with the same sign, such as 2 plus 5 and -2 plus -5. If the numbers have the same sign, add the numbers and keep the same sign. So, if I'm combining 2 positives, the answer will be positive. If I'm combining 2 negatives, the answer will be negative. Now, adding integers with different signs. If the numbers have different signs, subtract the numbers and use the sign of the larger number. For example, comparing 8 and -10, there are more negatives. So we subtract 10 and 8, and the result will be 2 extra negatives, -2. In the next example, -13 plus 17, there are more positives, 4 to be exact, and thus, by subtracting 17 from 13, we get the result of 4 and continue to use the positive. Now we can apply both these rules for adding, even if we have subtraction problems. Let's take a look. When we are subtracting integers, if the problem is subtraction, keep change flip. That means change the problem to add the opposite. Note, if the problem is already adding, you do not change it. Only change if subtracting. So, in the first example, we have 4 minus 2. We know the answer is +2, but let's change the red minus sign to adding, and then the green number that follows the minus to its opposite, 4 plus -2. The result is +2. How about -5 minus 5? We change the minus sign to plus, and we change the 5 to its opposite, -5. So -5 plus -5, using the adding rules from the previous slide, gives us -10. As you can see, we do not change the first number that leads in the expression. And do not confuse negatives with subtraction signs. In the third example, we have -1 minus -3. Keep the -1 that starts it off, change the minus to plus, and then find the opposite of -3, which is +3. Using the adding rules for integers with different signs, subtract 3 minus 1, and we get 2, and it is more positive, so it's going to be +2. Let's take a look at a more complex expression. -1 minus 1 plus -4. Again, we initially keep that first number, changing the subtraction sign to plus, changing the 1 to its opposite, -1, and again, we do not change the problem if it's already adding. That is why the plus sign stayed the same, and the -4 stayed the same. So it looks like they're all the same signs. That means we can just add them together. 3 plus 1 is 4. 4 plus 4 is 8. Since the signs are the same using the adding rules, the answer will be -8. Now let's review the rules for multiplying integers. See, the product of 2 integers with the same sign is positive. 2 positives multiply to get 6, and 2 negatives, these integers, multiply also to get +6. Now the reason we have this example using 2 numbers when the signs are the same is because there's an even amount of negative integers. In the first case, there are 0 negatives. That means it's going to be positive. In the second case, there are 2 negatives. That is an even amount, which will result in a positive integer. Now what if we have multiplying integers with different signs? The product of 2 integers with different signs is negative. So 2 times -3 is -6, because they are not the same sign. -2 times 3 is also -6 because they have different signs. Now, take a look at this rule. If the number of negative integers is odd, like 1, 3, 5, and 7, the product will be negative. In this case, not only are the signs different, but because there is an odd amount of negative integers in this expression. That results in a negative answer. The same rules apply to division. Again, The rules are, take the expression and multiply and divide like normal. Then we count the number of negative factors in the problem. Again, if there's an even amount of negatives, the product will be positive. If there's an odd amount, the product will be negative. It is very important to distinguish the difference between a minus or subtraction sign and a negative. We'll be applying all these rules together when we concern ourselves with the order of operations for more complex expressions. Let's take a look. Now, reviewing the order of operations, there are certain steps we have to take in order to get the right answer. Step 1 is to perform the operations in parentheses first. Step 2 is then to evaluate the exponents. Step 3 is to multiply or divide from left to right. And finally, step 4 is to add or subtract from left to right. A lot of you guys are familiar with PEMDAS, but remember, it's not always multiplying first before dividing, it's from left to right. Take a look at some of these scenarios. In this math problem, 6 times 5 divided by 10, we'll multiply first, then divide, because multiplying appears first from left to right. In this next problem, 12 divided by 4 times 9, we will divide first and then multiply, again from left to right. And scenario remains the same for adding and subtracting. 6 minus 5 plus 10, I will subtract first, then add from left to right. And finally, 12 plus 4 minus 9, I will add first, then subtract from left to right. Let's take a look at some examples. So, it wants us to evaluate this expression. 30 divided by the quantity 7 plus 2 to the power of 3 times 6. Let's perform the operations in parentheses. Go ahead and follow along. I will highlight the parentheses in red. That means we have to do everything on the inside first. And what do we have on the inside? There's adding and exponents. Should I add, then work out the exponents? Let's take a look at this list and what should we do first? We have to evaluate the exponents first before adding. So let's evaluate 2 to the power of 3. This is 2 times 2 times 2, which gives us 8. And now we have to combine the 8 plus 7 inside the parentheses to get 15. And now we have division and multiplying. What should we do first based on this rule? Do you think it's multiplying or dividing? Well, going from left to right, it looks like division comes first. So we will have to make sure that we divide 30 and 15. We get the answer of 2, and our last step is to multiply by 6. We get a result of 12. Remember, your work should look like this. You can call it an upside down triangle or the pizza method. It keeps our work organized, and we do one step at a time, writing the expression that still remains that's unused. Now it's your turn. Let's practice these two problems. Go ahead and copy this down on a sheet of paper and work this out using the order of operations. Pause the video while you work it, and then resume the video once you've completed the task. Pause the video now. Welcome back. Let's take a look. In this math problem, there's multiplying, subtraction, and division. We have to multiply, then divide from left to right, and finally we have to subtract. So when I say we have to multiply, make sure we're using the correct numbers, and when I say divide, the correct numbers as well before we subtract. So let's multiply 6 times 15. We get 90. We rewrite the remaining part of the expression that's not used. Minus 10 divided by 2. Now it's time to divide 10 divided by 2 and get 5. 90 minus 5 finally by subtracting, we get a result of 85. Did that match your answer? Great! Let's take a look at the next question. There are parentheses with exponents and subtraction inside. Aside from that, there's also adding and also dividing. What are the steps we should do first? And let's sort it from left to right. Parentheses, then we divide, and then we add. So inside the parentheses, we have exponents and then subtraction. Let's write the math problem and show it step by step. So inside the parentheses, we have to evaluate 5 to the power of 2. This is not 5 times 2. It's 5 times 5 and gives us 25. We rewrite the rest of the problem. And now we have to subtract in the parentheses 25 minus 7, and that gives us 18. Again, rewriting everything that's not used in the expression. Our next step is to divide 18 divided by 3, and we get the result of 6. And finally, our last step is to add, and 16 plus 6 is 22. Did this match your solution and work? Again, make sure that we show each and every step organized in a manner one step at a time. So now it's time for the homework. It'll be these same problems, so you may follow the same exact steps. However, there are now integers, meaning negative and positive numbers. Let's take a look. Homework questions. You must show adding the opposite for full credit. The instructions are to solve by using the order of operations. And again, if the problem is subtraction, change that part of the problem to add the opposite and show all work. So question number 1, the expression reads negative 6 times negative 15 plus negative 10 divided by negative 2. Question 2 reads negative 16 plus the quantity of 5 to the power of 2 minus negative 7 and divided by negative 3. The gray parentheses are to show you and identify what are negative numbers and not subtraction. Make sure that you assume that this 5 to the power of 2 minus negative 7 is in these black parentheses, and you can follow the steps from the previous slide. This homework is also available on eCampus to download, but make sure you use the video to help you with the portions of how to solve this step by step. Try to make your work look like the pizza or the upside down triangle method, showing all the steps. Turn your homework in by emailing it to me, a photo or the work typed up, to my email address, and make sure it's large and clear. Homework will be due Tuesday, May 12th by 11:59 p.m. Until next time.